In part 1 I modified the default Revit fitting into a cast iron fitting and I set up the lookup table for the short sweep bend only. Before I continue, I want to add the small lip at the end of each hub. This is just a visual detail, it will not affect the way we connect the pipe to the fitting. So if you don't care about this detail, you can skip this step. I'm going to use the sweep command, and first I need to draw the path of the sweep, and I will sketch a line that it will be in the center of this fitting hub. Just to be safe, I will use the align tool to lock it in place with the reference plane. I am also going to align and lock in place the left point of the line to the end of the hub and turn this temporary dimension into a permanent one. According to the catalog, the dimension of this lip for cast iron varies from 0.25 inches to 0.31 inches. Since this line is already a quarter of an inch, I will zoom out and find a little blue lock that will lock this dimension in place at a quarter of an inch dimension. Now I need to go back to modify sweep and check the OK because we're done sketching the line. After this I need to edit the profile of the sweep, and since I cannot do that in the current view, Revit will give me a pop-up window with the views where I can do that. I can now choose the left view and I will draw a circle. I want to make this temporary dimension permanent and I will associate it with a new parameter that I will name hub radius. Now I will hit the check icon one time because I'm done with the profile, and second time because I'm finished editing the sweep. If I go in my 3D view, this is how it's going to look like. I will set the view to realistic and change the level of detail to fine. And this hub needs to be slightly wider than the outside exterior diameter of the fitting. Therefore, I will go to Edit Type and I have to set the value for hub radius. I will copy socket outside radius and paste it in this field, and I will add, let's say, 0.03. This error is telling me that my hub radius parameter is not an instance parameter and it cannot be associated with a type parameter. I will select hub radius and hit the edit button. Now I can turn it into an instance parameter and this value is way too big. I will try 3/64 or maybe even less than that. This looks pretty good. Now I need to do the same for the other hub, and to do so I need to go back to reference view. Here I will go back to create and look for the sweep command and select sketch path, and I will draw a line in the middle of this hub where there is also a reference plane. I want to align and lock this line to this reference plane, and also I will align and lock to the edge of the hub. If I select the line, I see this temporary dimension of 1/4 that I will turn into a permanent one, and I will have to look for the tiny blue lock to lock it in place too. Since I am done with this sweep, I can click on the green check button, and now it is time to do the profile, and I will have to select the front view to edit the profile. Here again I will draw a circle, turn the temporary dimension into a permanent and associate it with the hub radius parameter. Now I'm done with that and I will check the OK button twice to confirm the changes, and if I go back into my 3D view, this is how it's gonna look like. In part 1 I did all the 90-degree bends, also known as short sweeps. Now next in the lookup table are the 60 degrees. And if I look for the word band in the catalog, and I should be able to find something called a six band, and here it is. I am going to use the snapshot command, which is Windows key plus Alt plus S on my keyboard to capture the dimension of this fitting. Now I'm going to move it here on the right side and get rid of the short sweep since I'm done with that. And using Alt Tab, I will bring back the lookup table. There is no such thing as 1.5 6 band, therefore I would have to delete this entire row. I don't need to modify the first three columns, and column D will be the same as the 2 inches row for the 90-degree elbow, which is 2.35. In this column, I need to find out what is the distance of this straight line right here. And same like I did with the short sweep, since I don't have this dimension, I will have to go to the short sweep family that I downloaded from the manufacturer website and get this dimension from there. And there it is. I will double click on it to open the family editor. I want to go to reference level in order to pull a dimension. I will set the level of detail to fine and shade it. Go to the family types in properties panel to make sure this is a 2-inch 6 band. These dimensions are a little too distracting. I need to change the scale to make them smaller. I will measure from the end of the hub to the point where it starts to arch, and that is pretty close to 1 inch. So I'm going to add 1 in column E. This will be 0. This will be same like column D. And column H needs to be 3 and a quarter minus 1 that is already inserted in column E. Therefore, the distance of the fitting has to be column E plus column H. Now I am going to repeat the same procedures for the other dimensions and angles, and I will fast forward for that. In summary, all I do is to find the right dimensions using the manufacturer website Revit family and the dimension catalog and insert them in the right place in the lookup table. If I need to, I can also delete or add rows to make sure I have only the sizes in the catalog. And don't close the video yet because when I'm done, I will troubleshoot this fitting because there will be some errors that need to be addressed. And I also will show you how we can set up a schedule for this fitting. Before we continue, I just realized that I did not have a row for the 90-degree elbow of 5 inches. So I will quickly add that using my super fast forward skills. Now that I fixed that, I need to save and import a new lookup table by going Family Types and clicking Manage Lookup Table. I click Import, and this is the one. I will click Yes to replace it. Now I need to go through a few sizes to check if my dimensions are the same with the ones from the catalog. But to do that, I want to change the size of these dimensions so I can spot it better. I will duplicate the existing one and set it to bold, and the size I will set it to 9/32. Right now I show a 40-inch 90 degree. Let's see how the 2-inch 90 degree looks like. So the dimension I have is 6.5 and the dimension in the catalog is also 6.5, which is right. So now I'll go again quickly through every size using my fast forward abilities. Now, since I got to the 60-degree bend, I will notice the first error. The top half is crooked, so it seems that the sweep was not the right approach in this case. I will zoom in a little bit and delete it. Instead, I will make an extrusion by going to my 3D view, and first I need to set up my working plane, and I will do so by checking Pick a Plane. Now I can create a circle starting from the center of the hub all the way to the exterior. I want to pull a dimension, but I need to go in an elevation view to do so. Now I can turn this temporary radius into a permanent dimension, then click on it and associate it with the hub radius parameter. And since I'm done with this, I can click on the green check mark, and if I go back to the reference level, I can set up the depth of this extrusion by dragging the blue arrows, and I will create a dimension. And since I inverted this extrusion from the reference plane, now I will have to set the extrusion end to minus 0.25 inches, and also I can lock it in place. In order to check this dimension for a 60-degree bend, I want to find a point close to this dimension that is called center radius, but it seems like there is nothing to snap to in this area. So the best thing I can do is to pull a new dimension from the other end and look for the intersection of these two reference planes, and this dimension is 5 1/4. And it does not make sense because if I go back to my lookup table on the row for 2-inch 60-degree bend, I have column E of 1 inch and column H of 2.25. Therefore, the dimension should be the sum of the two, and it is nowhere close to that. I will save the project, and in order to find out the answer to this issue is to go back to family types and look at the formula for socket depth. Because if you remember from part 1, that extended piece is actually the initial socket of the default PVC Revit family that you can find in the pre-installed family library. All I need to do to fix this is to add a comma and the word angle with a capital A, 1, as soon as I turn off my caps lock. And this angle 1 is actually a parameter that is here at the bottom, and then when I click on apply, now the family pulls the right row from the lookup table. And I will just change this dimension because I will still want to double check the rest of the fittings. Now let's take a look at the formula so we can understand it. If I select the whole formula and copy it, I can paste it into my notepad. The formula says in order to set the dimensions, look up for lookup table name, which is a parameter that can browse the lookup table in Excel format. Then in quotes it says SDPT, which means socket depth, and it means look for column E. Then there is a comma after which it says zero point 0.5 of nominal diameter, this being a default value in case if there is no valid input. Then there is another comma after which it says nominal diameter, which is a parameter in the family and also is defined in the table under column A and B. But since in the table there are 4 different fittings with a 2-inch value, the family was picking up the first row value, which was for 90 degree. Therefore, by adding a comma and the word angle 1, now this family will pull a value from the row that matches the diameter and angle in the same time. Okay, now I will go ahead and fast forward while I check and fix my dimensions and maybe add some if anything is missing. All these are rounded up dimensions, and if you know the exact dimensions, and as long as the sum of column E and H is equal with the dimension in the catalog, then E and H don't necessarily need to have the same values I used in this video. And there is also a bend of 72 degree that I did not add in this video, but if you want to add that too, it is the same procedure. Just create a new row, set the fitting size, the angle, and the necessary dimensions. Save the lookup table and reload it again in the family. Now, this cannot be a cast iron fitting if I don't set the material to cast iron. I need to go to Manage and click on Transfer Project Standards to open the dialog that allows me to bring the materials from the same project I have open. That project has some manufacturer website fittings that have the right cast iron material, so that means now I am transferring all the materials, including that one I need. That's why I won't override, but I will click New only. When I hold Control on my keyboard and click on all these components this family is made of, I can go here in the Properties panel where it says Material, and toward the end of the box there is a tiny square that will show up where I can set the material to cast iron. Now, one last thing I like to do is to set up the way I can show this fitting in a 2D plane. I make a big square selection and go to the bottom right to filter this selection. I want to select nothing but the lines. Now, while I have these elements selected, I can go to these tiny glasses and isolate these elements. I select these four extended lines and I can set up in which instances I can see them by clicking on Edit Visibility Graphics. Here it says I can see these lines in coarse and medium views and only in plan view. I want to uncheck coarse. This way on my coarse view I have a lower level of detail than in medium. I can now reset the temporary isolation, and before I will play with this family, there is one more thing I need to do. There is a reason why angle 1 is used in the lookup table. This angle is rounded up to either 22.5, 45, 60 or 90 degree. Even if the pipe will be drawn at a weird angle, let's say 37 degrees, this formula will round it up to the closest available angles that I described earlier. So this formula will allow me to choose the threshold of my rounding up. I'm going to paste it here. There is no smaller and equal in this formula, therefore it needs to be angle smaller than 30 or angle equal with 30 in brackets, then a comma, then the angle 1 will be 22.5, and then if angle smaller or equal than 52 degrees in brackets, comma, which means then angle 1 should be 45 degrees. If angle smaller or equal than 75, then angle 1 should be 60. Then there is another comma, which means if none of these apply, or in other words, if it's bigger than 75, then just make it 90. And if you want to add the 72-degree bend, this must be included in this formula too, otherwise it is not going to work. Let's test it out now. As you can see, angle 1 is grayed out because it's controlled by the formula, not by input. But I can change the other angle, and this will be the actual angle when we model the pipes. If I type 21, then angle 1 is 22.5. If I type 46, then angle 1 will be 45. And finally, if I type 70, angle 1 will be 60. Now I am finally ready to load this fitting into my project, and I will place it somewhere right here. I need to add this fitting to the routing preferences of this cast iron pipe, and under elbow I will select cast iron bend. I apply the changes and I will use the pipe command to draw a pipe, and I will make a 90-degree angle, a 45-degree angle. I will draw one at approximately 60 degree, and one at 20 degree. And if I select these fittings, here in the properties panel I can see the angle, and this one is 62 degrees. But if I scroll down, there is that angle 1 I was talking about, which is 60. Same with this other one, which was drawn at 20 degrees, but angle 1 shows 22.5. Now the question is how we differentiate these fittings in a schedule, because we can pull the sizes, but how do you know the difference between a short sweep and an 8 bend? I will have to use the angle parameter to sort out the fittings by angle. But if I go to schedules and I look for pipe fittings, I can see that I have find something called size, and if I scroll up I can also find something called count, but there is nothing called angle. The solution is to create a shared parameter and associate it with the angle in the family. Under Manage tab, I can find Shared Parameters icon. Here I will click Create and I need to save the parameter, so I will click Yes. Let's go to the Downloads folder and name it New Parameters. Then I'll click OK. Under Groups, I will click New and name it the same. Then under Parameters, I will also click New and name it Shared Angle. And for the type of parameter, I need to select Angle from the drop-down menu. Click OK twice and go back to the fitting family, straight to the family types, and I will click to create new parameter icon where I can check shared parameter, and very important it is to also check instance, because this will be one type of family but with different angles for each instance. Now I will click select. I have the option to select shared angles that I just created earlier. Now this parameter does not have any value, but I can associate it with a parameter called angle1, the same one we talked about earlier. I will copy it and paste it in this column here where there is a equal sign. Now I press apply, OK, load the family again into the project and overwrite it and parameters. Now when I go back to my schedule, in properties I will select fields and press S on my keyboard to jump straight to shared angles. And when I click OK, I can see that currently I have in my project one of each bands with a size of 3 inches. And the reason I have these blank rows is because I also have some husky bands in the project that do not have an angle. And to make it more clear, I will go back to fields and look for family and types and select it. And under sorting and grouping, I can sort everything by family and type. And I could also uncheck itemize every instance if I wanted to, in order to have a total of each. But I won't do it because I don't have that many elements in my project. Now after I click OK, I will have each fitting shown by size and angle.